Welcome to section 6.0 Rules of Exponents. This is a review section from Algebra 1. This is going to be real basic about the rules of exponents. And we're going to take these rules and apply them to all things in Chapter 6. So we really need to be solid with these rules. The first thing I'm going to say is if you have 5 to the second power, this is called the base. And the little 2 right there is called the exponent. And what the little exponent does is it tells you how many times to multiply 5 together. So we have 5 squared, we say, so it'd be 5 times 5, which is 25. Sometimes people get tricked up and they think that that's 10. So if you have 5 to the third power, it means 5 times 5 times 5, which is 125. So the base is the big number and the little number is the exponent. And it's repeated multiplication. So that's what exponents do for us in the beginning, and then they do so much more for us as we learn about all the different kinds of exponents. But in the beginning, we just understand that exponents tell us repeated multiplication. How many times does this 5 show up? If it shows up 3 times, and we multiply it together 3 times. It doesn't mean 15. That's where we get ourselves into trouble when we're doing this. So here are the main rules of exponents. Rule number 1 is addition. So when you have x squared times x to the third power, we get x. When we have these like bases, see those are the bases, they're alike, and the exponents, they can be different of course, but when the bases are alike, we add the exponents. So it's x to the fifth power. So x squared is x times x, and x cubed is x times x times x. So that would be a grand total of 5 x's being multiplied together. So that's where that comes from. When you multiply like bases, we add the exponents. Number 2, the second rule, if the first rule is addition, you guessed it, the second rule is subtraction. So the second rule being subtraction, we have x cubed divided by x to the fifth. So this is division, but the subtraction is telling us what to do with the exponents. So when we have these two like bases and they're being divided, we actually subtract the exponents. We get x to the negative 2 power. It's the top one minus the bottom one. So it's 3 minus 5 is negative 2. Then I'm going to do another rule here, which says you can change any negative exponent into a positive exponent by crossing the fraction line. There's an invisible fraction line right there. And there's an invisible 1 here that doesn't move. And this is going to go down to the bottom, and it's going to join forces with this invisible 1. So this is invisible, and that's invisible. So what happens is this character right here drops to the bottom. So the 1 now shows up on the top. The 1, you can write it here or not write it there. So you can write it or not write it, x to the squared. And that 1 really isn't necessary there. So basically all that's happening is the x to the negative 2, you throw it to the bottom and above the fraction, and you make it be positive. I'd like to say something else about negative exponents before we go on. And I call this the cross the line and change the sign. So you cross the fraction line and you change the sign. And it works either way. You can go from the bottom of the fraction to the top of the fraction. Either way, when you cross over the fraction line, you change the sign of the exponent. I would like to say something about this in regards to scientific notation. So if you have scientific notation, and you have 3 times 10 to the negative 4th centimeters, and you ask yourself, is that a big length or a small length? Well, actually, it's just a small length, because if you remember, you grab the decimal point and you throw it over there 4 spaces. So it's 0.0003 centimeters. So the decimal point was here at the end, and you're going to grab it and move it over 4 spaces. So that's the measurement, which is a pretty small measurement. But what does this mean here? Well, if we think about it in terms of exponents, you cross the line and change the sign. So it becomes 3 over 10 to the 4th power centimeters. And that would be 3 over, well, 10 times 10 times 10 times 10 is 10,000 centimeters. So it's 3 10,000ths. So 3 over 10,000 is 3 10,000. 3 10,000ths. And actually, if you read this number up here, that's the proper way to say it. Instead of saying 0.000, right, you would go tenths, hundredths, thousandths, 10,000ths. It's 3 10,000ths of a centimeter. So the negative exponents, you've seen them before, scientific notation, but maybe you didn't make that connection to crossing the line, changing the sign, and all that business. Okay, so we have two rules so far. The addition rule, when you multiply like bases, you add the exponents, and the dividing, so when you divide like bases, you subtract the exponents. Okay, there's two more rules. Rule number, we'll put it up here. Rule number, oh, I got to be able to see it though. Rule number 3. We're going to call this the multiplication rule. That makes sense. If we have an add, subtract, we're going to have a multiply rule. Multiplication rule. And it says that if you have x to the second power and then that gets raised to the third power, you have an exponent raised to an exponent situation. So that's going to be a multiplication of the two exponents. So it's going to be x to the 6th power. So when you have an exponent raised to an exponent, you multiply the two exponents together. Now, does that make sense? Because this 3 here means there's 3 of these. So it'd be x squared times x squared times x squared. So 2, 4, 6, 2, 4, 6. So you would multiply, which means you're adding these together. So that would be x to the 6th. Or you could think about this as x squared times x squared, or excuse me, x times x, and then the x squared here is x times x, and this squared is x times x as well. So you get x to the 6th no matter how you slice it or dice it. And the final rule, I like to call this the one and done rule. The one and done rule is when you have anything to the 0 power, you get 1. It's not 0. Anything to the 0 power is indeed 1. Except, there's one exception, 0 to the 0 power is undefined. You can't do that one. In fact, if you try and type it into a calculator, let's see. If you try and type it into a calculator here, you have 0, and you raise it to the 0 power, you get error. It don't work. So there's the one and done rule. Anything to the 0 power is 1, except for 0 to the 0 power, which is undefined. So here's the 4 main rules again. When you multiply like bases, you add the exponents. When you divide like bases, you subtract the exponents. If you get a negative exponent, throw it on the top or bottom, switch it between the two levels of the fraction, and you change the signs across the line, change the sign. Multiplication, when you have an exponent raised to an exponent, you multiply. And the one and done rule, anything to the 0 power is 1. Now I'm going to take you through the assignment, which is on page 360, 1 through 18 all. And I'm going to take you down the left-hand column, which is 6 problems. So here we go. If you need to pause it for a second, grab the book or whatever, get out a piece of paper, go ahead and do so. Number 1 is 2a to the 3rd power, and that's multiplied by 5a to the 4th power. And I can tell it's multiplied because there's no symbol in between there. Now this is really weird when you first start this, because I taught you the rules for the little tiny numbers, but the rules for the big numbers, the 2 and the 5, are always the same, right? This is a 2, that's the number 2. That's not the number 3, that's the exponent 3. This is the number 5, and that's not the number 4, that's the exponent 4. The number 4 and the exponent 4 mean two different things, don't they? So regular numbers do regular things. 2 times the 5 would be 10, and then it's a. When you multiply, you add a to the 7th. Answer. Done. The next one is number 4, and that one is 3x to the negative 4, and then, oh, miswrote it, 3x to the negative 4, and then it's y to the 3rd, and then squared. Okay, here we go. So everything inside here gets squared. 3 gets squared, so 3 squared is just 9. And the x to the negative 4 gets squared, so you have a power raised to a power, so you remember what to do with that. Power raised to a power, exponent raised to the exponent, we multiply, so it's x to the negative 8. and then 3 times 2, because it's an exponent raised to the exponent again, is y to the 6th. Then we cross the line, change the sign with just this guy here, because the negative exponent's only affecting the x. So the 9 stays on the top, the y to the 6th stays on the top, and the x to the 8th goes to the denominator position. Number 7 is 6x to the 3rd raised to the 0 power over 3x y squared. So now we get to use the one and done rule. Anything to the 0 power is just 1. So it's 1 over 3xy squared. And there's nothing to do with this. You can't multiply these together because they're not alike. So you have to have like bases in order to add the exponents. And the 1 over 3 is like 1/3. There's nothing really to do with that except for just leave it like a fraction. Number 10. Number 10 is 2x cubed y to the 7th over -2. So I'm going to go ahead and just throw this on the bottom of the fraction. I got my invisible fraction line there. So cross the line, change the sign. So it's 1 over 2x cubed y to the 7th, and then all of this gets squared. So that's what I'm going to do, is I'm going to square it just like I squared everything up in question number 4. So it's going to be 2 squared. 2 times 2 is 4. Power to a power, so you multiply x to the 6th, power to power, y to the 14th. Boom, done. The next one after this is number 13. Number 13 is r squared s to the 4th t to the 6th over r to the 3rd s to the 4th and t to the -6th. So what we're going to do with this one is we're just going to go right through it, and we're going to get doing the division, right? When you divide, you subtract the exponent. So this is a subtraction one. So remember, it's the top minus the bottom. So it's 2 minus 3 would be r to the -1. 4 minus 4 is 0, so it's s to the 0 power, and that's going to go away in a minute. And then t, it's 6 minus a -6, so it's a double negative. 6 minus a -6 was actually going to be 12. And that makes sense too, because you could take this, throw it up to the top, and it'd be t to the 6, and then you could just add this 2 6's together. All right, the t to the 12th stays in the numerator position, stays on the top of the fraction. The s to the 0 is 1, and then r goes to the bottom. And you leave it r or r to the 1st power, it doesn't matter. Okay, 16 looks like a hot mess, but it's not too bad if you break it down into its parts. Little focus there, hocus pocus focus. 1 over h to the -2, and then raised to the -1, and then times h cubed. So here we go. We're going to do the exponent first, like thinking order of operations. No matter what math we do, whether it's pre-algebra, calculus, algebra 2, it makes no difference. We always follow the order of operations. So it's going to be 1 to the -1 power. Well, the good news is 1 to any exponent is 1. So 1 to the -1st power is just 1. And if you take 1 and you move it to the bottom of the fraction, it would be 1 anyway. So, but there still has to be a 1 on the top of the fraction, because you can't have nothing over something to be a fraction. You have to have 2 parts of the fraction. So it's going to be 1 on the top, and then when you have an exponent raised to an exponent, we're going to multiply, so it's h squared times h cubed. Now the h cubed is really over 1, and then we can multiply our fractions together. Numerator times numerator, denominator times denominator, top times top, bottom times bottom. That's how we multiply fractions. So it's h to the 3rd, 1 times anything is itself, 1 times anything is itself, h squared. Then we have this situation here. When you have like bases and they are divided each other, we just subtract the exponent. So it's h 3 minus 2 is 1, so you can call it h to the first power or just plain old h. All right, there we go. That takes you through the left-hand column. Remember, these are the rules that we just did. The addition rule: when you multiply like bases, we add the exponents. When you divide like bases, you subtract the exponents. If you get a negative exponent, cross the line, change the sign. When you have a power to a power, you multiply the exponents. And anything to the 0 power is 1. It's the one and done rule. So go ahead and start working on 360, 1 to 18, and we did the left-hand column, so that leaves you the middle column and the right-hand column.